So if you still remember, you have certain signal in the analog, RT, some signal, alright, and then you're gonna transform it, you're gonna discretize it as R star T. You have all this line all over here. Alright, so I'm taking each of the sample points, I'll have this R star T. Alright, next we're gonna have the RNT. Alright, we somewhat wants to so-called zeroth order hold it. At this point we hold, and then after that when it takes in the value over here, alright, it zoom, and then over here it hold until this point, it touches this point over here, it zoom out again, alright, so it zoom, and then things like that goes on all the way for the zeroth order hold. Alright, so in this video I'm going to briefly discuss with you the aliasing issue, because in the more in-depth this is really tough. So this is just a summary of what I've known so far. So you have an analog signal, this is your digital signal, in between you need to discretize, so you somehow need to sample. Alright, so over here you're going to sample your stuff, and if you were to sample with a lesser frequency, so for example if you have a signal that is like this, very fast, alright, however when you sample your whatever stuff, you only sample this point, you sample this point, and this point, okay, maybe some other points, maybe this points also lah. So when I have something like this, alright, I may take in, wow, what am I drawing, man? But anyway, I may take in some weird values like this, okay. Wow, that's not cool for one about. Okay, over here, right, if I were to connect this point, I'll have something like this. Alright, as you can see, this red color one is somewhat lagging behind the black color one. Because if you want to sample the black color one, you need to take this point, you also need to take this point, you need to take this point, you need to take all these points. You see, so you need to take all these black points, and then you're just gonna connect them. Alright, so these black points over here, as you can see, this is one time I take, this is another time I take at this point, and then another time I take this point, another time I take this point. Alright, however for the red color one, as you can see, I only take 3 points. I only take this point, I only take this point, and I take this point. So my sample frequency is somewhat bigger. Then you see, this is only one sample frequency. If you see the difference between two samples, this is one sample, this is second sample, right? Maybe I should use a different color, blue color. Okay, over here this is one sample, this is second sample, so the distance between these samples is the frequency, right? I think you get what I mean. So this is the frequency between the two samples. Alright, but over here you see the frequency between these two samples is freaking hell big. Alright, so therefore it's very slow, so you only take in partial of the signal. Alright, and this problem, so therefore when you're taking partial of the signal, you only come out partial of the signal, so you will not get full signal, and you may have distortion all over. Alright, and this is therefore called the aliasing issue, alright, or the aliasing problem or effect or whatever. Alright, so therefore one recommendation is that your frequency, alright, your sampling frequency must be equals to 2 omega, good job, why is that, omega O, alright, your original signal. Okay, so the sampling frequency has to be at least 2 times your original signal. So if your original signal, for example, this is your original signal, right, the black color one, if your original signal is equals to 50 Hz, you requires 100 Hz of sampling frequency, alright, in order to sample everything over here. Alright, and this is the point where we start to get the point where, what the hell, why do we take 2 times? Alright, and therefore this is the purpose of this video, by summarizing what I've known so far in the more in-depth way. Okay, so let's start. Alright, so therefore in the RT system, okay, when you were to plot this RT system is what? This is the time domain, this is the magnitude domain, or the amplitude of the signal. Alright, in this case we are actually plotting frequency against the magnitude and amplitude so far. Alright, and we can actually draw this thing in terms of something like this. Okay, you can draw something like this, which is in your lecture, or you can draw something like this, for example. Okay, we can call this the RT signal for the frequency and amplitude domain. This is the spectrum. Alright, so therefore this thing over here for RT analog signal is only one spectrum. Alright, however, because of some derivation, which is hard for me to prove to you, your r star s over here, alright, is a summation of all your, alright, this over here rt, if you were to Laplace, is rs, right? So this thing over here is your, actually I should have written this thing over here as rs also, okay? So as from the PPT itself, as you can see, this thing over here includes your rs, your initial analog, minus away certain sampling frequency. Okay, this is the point where I don't know what the hell is going on. But anyway, for your summation point over here, you're somewhat summing up all the rs, sorry, so your analog signal. So instead of only one this thing over here, you will have many peripheral signals all over that they stack up all along. Alright, and this stack up all along, maybe I should draw a lower one, something like this. They are the same amplitude lah, but I just want to illustrate this point. Alright, where this point over here, for example, if your magnitude is somewhat 3, okay? So however, because the black color one and the red color one adds up together at this point, at this particular point, instead of showing the amplitude of 3, it's going to show up as amplitude of 6, which is somewhere over here. Alright, and therefore when it's going to flick back to your frequency domain, this is the frequency, right? As you can see, you are somewhat slower, you see. And therefore, due to this particular system, that because you have read your frequency as too slow, alright, this is therefore when you're going to sample your frequency, your initial frequency is something like this, right? So when you're going to sample your frequency, you're going to sample something too slow already, because of this thing over here. But you may think like like that lah, but in terms of equation, I don't even know what the hell is going on. Okay, but in terms of the understanding is something like this. Alright, at first I also thought like that lah, quite easy then when I start to do macam, this thing over here is r star s. Alright, this is rs, this is r star s, should be this one, okay? But anyway, so over here there's a problem. So what can we do? Alright, if you still remember, our sampling frequency has to be equals to 2 times your omega naught, your original frequency, right? So if such of the case that happens, your graph will look something like this for your r star s. Okay, you have this original signal, just nice it don't cross. Alright, just nice it's just all along like this, all the way goes to minus infinity, blam 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 blam, all the way. Okay, very nice, sweet. Okay, however, if it's for omega s equals to, maybe larger than 2 omega naught, your original frequency, if you have a separate frequency that is way larger than your original frequency, what you have is something like this. Bam, lag a bit, but not lag, but rather than bam, like that, bam, and then all the way. Alright, so they are very safe, alright, because these are all frequencies lah. This is all frequency. So in some sense, it's not lagging anything. But anyway, just to let you know. Alright, and then as for your omega sampling, if it's smaller than your 2 times of your this thing over here, this is where you see this thing happens. Alright, they're gonna crumple up all along. They're gonna overlap each other at this point. They're gonna overlap and overlap and overlap, you see. Alright, so therefore this is the meaning of how this thing actually corrupt your aliasing system. Alright, so over here this is the Excel from the Zoe's one. Alright, his Excel sheet takes cosine 7 pi over 3 and cosine pi over 3. He's gonna compare between using this scenario over here. Alright, where your cosine pi over 3 is somewhat the slower one, while your 7 pi over 3 is your original frequency. So when you're sampling your cosine pi over 3, what is the somewhat the meaning behind that? Alright, at first, in order to reach the same signal, 0.75 as you can see, alright, your cosine 7 pi over 3 and your cosine pi over 3 is the same. Alright, if I am lesser, alright, you see, if you are slightly lesser, I'll have a lagging. Alright, if I are somewhat lesser again, maybe 0.71, you see, I'll have lagging. And with 0.5, which is more or less, I'll have a lagging. Okay, and this step over here, this 0.5 thing over here, okay, is the difference between each of this x. Alright, this x is your x-axis lah. Alright, where is your frequency? Alright, is the difference between your time. I should say that is difference between your time. Okay, So each time step is 0, 0.5, 1, 1.5, 2, 2.5. So it's just it's just the add up of things. And just when I thought that if I would put 0.75, this is nice. So if I were to put 1, if I were to put 2, you see everything they are the same already. They put all together already. But this isn't the thing. If I were to put 0.76, this is where the problem comes in. I have a lag. I have a lag between cosine 7 pi and pi. And 0.8, I have a more lag. 0.9. Sorry, what am I doing? 0.9. You see, I have way more and more weird stuff until 0.99. You see, another thing, and then up to 1, like that, nice. 1.2, then you see, lag again. 1.3. So I think it's something to do with the radian itself. So there is more in-depth system that I really don't know, but I just put it over here. So therefore this is just a summary of what I've known. So in the future, if you happen that you know anything, I'll just do a new video or whatever. Alright, so this is just the part on the aliasing issues, and only thing that you need to concern of is this thing. Okay, this thing over here. So in the next video, we're going to discuss about the low pass filter and zeroth order hole. Why do we use zeroth order hole in the end? See you there.